Hi Year 10. Because I'm not here for today's lesson, I thought I'd just make a video going through the worked examples for you. So by now you should have read our introduction to the addition rule as well as writing the rule down. You should have also watched the video on Atomy on the addition rule as well as completed the quiz. If you have gotten up to these worked examples, you might be a-okay with going through them. If not, watch on. I'm just going to go through the two from the Cambridge textbook, so the textbook we use, but there are other worked examples from other textbooks here for you. So our example 6 is applying the addition rule. Our situation is a card is selected from a standard deck of 52 playing cards, so four suits, we've got no jokers. We're going to let A be the event of the card is a diamond and B be the event that the card is the jack. So this example is really nice for us and it steps it out. It wants us to find the number of elements in A, the number of elements in B, and the number of elements in A and B. The reason for this is so when we substitute into the addition rule, we already have our numbers for this. We then need to find our probability of A, probability of not A, and the probability of A and B. We then use the addition rule to find A or B, and then we find the probability that the card is a jack or not a diamond. So first thing we want to do is our number of A, which is the card is a diamond. So there's 52 cards. We know there's 4 suits, so we just divide 52 by 4 to get 13. So a quarter of the cards, or 13 of these cards, will be a diamond. For event B, we want the number of elements of the card being a jack. And we know that there is a jack for each suit, so it's going to be 4. Finally, we want the number of elements in A and B. So remembering, this is our center bit of our Venn diagram where they overlap. So we want to know the number of elements that will be both a diamond and a jack. And there's only one card in a standard deck that has this. For B, we're then going to find the probability of A, not A, and B. So our probability of A is we put our number of elements in A, which is 13, over our total number of elements in the set, which is 52. 13 over 52 can be simplified to 1 over 4. The probability of not A, you could go through and add up all the individual probabilities of everything else, but we know that our probability always has to add up to 1. So we can do 1 minus our quarter, which we found as the probability of A, to find the probability of not A, or the complement of A, as 3 over 4. Our next one's the probability of A and B. So we know the number of elements in A and B is 1, so it's just going to be 1 over 52, and this can't be simplified any further. Next, we're going to use our addition rule. So we start off by writing PR, so our probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. And if I scroll over here and scroll back up to the, will it fit? Yep. So we can see A or B is everything that's included in our circles. So if we find the probability of A and the probability of B, this part where we intersect, we're actually accounting for it twice. So that's why then we need to minus one of them off. So if I scroll back to that example, so probability of A is 13 over 52. The probability B is 4 over 52, and we know these because we did it earlier on. So there's my 13 and there's my 4. Yes, we can simplify these, but to be able to add the fractions, remember we need to have our denominator the same. I'm then going to minus the probability of A and B. So that center bit that we account for twice when we add these two probabilities together. So that's going to be minus 1 over 52. We end up getting 16 over 52, which we can simplify to 4 over 13. For D, we want to find the probability that the card is a jack or not a diamond. So I'm going to say the probability of jack or not a diamond. So it's going to be the probability of B, then or is like a U symbol, and then not a diamond we can write as not A. So for this, we're going to again use the addition rule. So the probability of B plus the probability of A minus the probability of B and not A. So we know the probability of B is 4 over 52. If our probability of A is 13 over 52, our probability of not A is going to be 39 over 52. So when we add that 39 and that 13, we'll come to 52. And then we're going to minus the probability of B and not A. So remembering that B is that it is a jack, and not A means it's not a diamond. So we know there's 4 jacks in the set of cards. One of them is belongs in set A, so that just leaves 3 that meet that criteria. So we do 4 plus 39 minus 3 to get 40 over 52, and then we can just simplify that to 10 over 13. Our next example is worked example 7. So 2 events, A and B, are such that our probability of A is 0.4, our probability of B is 0.8, and our probability of A or B is 0.85. So they're not actually giving us the numbers, and we don't need to figure out the numbers. This is where our knowledge of algebra comes in handy, as we will have to substitute into the formula and rearrange. So you can see here we've written the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So that's just our addition rule. And we're wanting to find that probability of A and B. So I'm going to put in my 0.85, which I'm given up here, my 0.4 and my 0.8. So I've substituted them into the formula. I've then done my 0.8 plus 0.4 to get 1.2. I then want to get the probability of A and B on its own, but I want it to be positive. So what I'm actually going to do is I'm going to add the probability of A and B to both sides so that this side cancels out my right-hand side, and I now have it on my left. I'm then going to minus 0.85 from both sides, so I end up getting this line here, that our probability of A and B equals 1.2 minus 0.85, and we get 0.35 for that. Finally, we want to do the probability of not A and not B. So remembering that when we first did our Venn diagrams, when we were doing set notation and looking at this, that the probability of not A and not B is the same as saying A or B not. So if I look at this, A or B, it's not, so it's basically everything around this outside. Yeah. So what I'm going to do is I'm going to do 1 minus 0.85, and the way I get my 0.85 is because I'm told here A or B is 0.85. So if I'm doing not that, I can just do my sum. So we remember all our probabilities add up to 1. I minus my probability of A or B to get 0.15. And this corresponds with A or B not. So remembering this is the same as this. And because we know the probability of this, we can do 1 minus that to get this answer. This one is a little tricky. This would be a high B, A type level question. It is not easy. Hopefully, as we continue on and you get more familiar with the symbols, it will come easier for you.